Hello, everyone, and welcome to today's webinar. Thank you for joining us. We will be taking all questions at the end of the presentation, but please send them in through your Q&A chat box at any time during the presentation. Let's go ahead and get started. Let's see, Amy, would you like to take it away?
Sure, thanks. Hi, this is Amy Jiron with the Building Technologies Office in the Department of Energy. Thanks for joining, everyone. We're working on getting Hayes Jones on the line. We're having a few webinar difficulties. Hopefully all of you are connected and up and running at home in this sort of unique environment. But yeah, so I'm just gonna fill in for Hayes for this next few minutes, and if she's able to join, we will let her continue. Welcome to our validation webinar. We're gonna talk about 3 different technologies today. In addition to the structure of field validation through the Department of Energy. So the speakers that we have today are from LBNL, so Lawrence Berkeley National Lab, from the Department of Energy, and from the Federal Energy Management Program. This is the agenda. This is the path that we're going to take through the webinar today. First, we're going to talk about what we're doing together across different programs within DOE's Energy Efficiency Renewable Energy Division. We're going to talk about what it means to participate and why you might want to do that. And then we're going to have 3 other speakers give an overview of the 3 technologies that are ready for technology validation in host sites today for you. And then we're going to have plenty of time for question and answer. So you can go ahead and type your questions into the question box on the webinar, and we will go through those at the end of the presentation. So hopefully you'll have some good questions for us. And if we cannot answer them for whatever reason, we will follow up with you right away. Marissa, you can go ahead to the next slide. I'd ask also, if you are unmuted for some reason and you hear yourself, go ahead and mute yourself. So what we're doing here is technology field validation, and that is a joint cross-cutting collaborative effort with the Federal Energy Management Program, the Weatherization and Intergovernmental Program, especially the State Energy Program, the Building Technologies Office, and the Advanced Manufacturing Office. We are working to not only identify technologies for field validation, but we are also working together to identify host sites for those technologies. And I think this will be an ongoing effort that will benefit you for the longer term, in addition to right now. So today's webinar is about sharing a little bit of technology information with you so that you can understand if there's a potential opportunity in your agency, in your building portfolio. And then we will follow up with you on the specifics of that. So we're not going to be able to answer questions about your specific building today. However, we will be able to follow up with you later to talk more about that. Hang on, I'm just going to see if Hayes is able to join. She says she's on. Hayes, can you talk? Can we hear you? Okay, still working on it. I'm going to keep running through the slides here. And Marissa, if you can let me know when Hayes is... Oh, is that Hayes?
Perfect. Hi, Amy, this is Hayes.
Okay, great. Take it away, Hayes.
Excellent. Well, thank you. Sorry for my technical issues there. So as Amy was saying, we are, I'm Hayes Jones with the Federal Energy Management Program, and we are very excited to be collaborating with our other offices on these efforts to identify, validate, and move forward DOE-supported technologies, as well as meet federal agency missions. So Marissa, if you could go to the next slide, please. So just a little bit about the opportunity for federal agencies and how we really would like this partnership to work, and between the R&D organizations and EERE and our federal agencies. So we're really hoping that partners can benefit, our partner agencies can benefit from learning more about these emerging technologies to support your agency's mission. and that the partners, the agencies who are doing these field validations can really contribute to the real world requirements to help inform the research and development around these technologies by identifying real issues and making sure that the R&D, the people doing the research and development really hear about those real world problems. And so really what we're trying to do is create this open pathway to identify two-way communications and really meet a range of technical needs. Marissa, if you can move to the next slide. So some of the benefits of participating in this technology validations is you'll be working closely with the DOE managed validation partners from our Building Technologies Office and our national labs with installation and deployment managed by subject matter experts here at the Department of Energy. Really help to develop those use cases. So we're really interested in gathering information on how these technologies perform in the real world and working with the subject matter experts to gather performance data and understand how you're using the technology in the field. And then looking to put these into a controlled investment, so reducing financial and energy waste and cut operational costs. We're hoping some of these new technologies can really help to contribute to your mission and help us achieve as a federal government some of our overall objectives as agencies. So support your mission, and then really for the visibility to help make sure these are highly visible projects that can really help demonstrate our emerging technologies. So I wanted to turn it back over to you, Amy, to talk about the next slide on what is a field validation.
Great. So hopefully some of you have participated in field validation efforts. Green Proving Ground, ESTCP are both similar programs to this with slightly different tweaks. So what we will do is work with you to find a great host site with people and operating normally to install the technologies, the three technologies that you're going to hear about. We will work with you to make sure that those are commissioned correctly and install any instrumentation required in order for us to do the verification. So that could be a variety of different things, mostly metering, I think. And then the data collected from those instruments will be used to evaluate the performance of the technology. So we'll be looking at the energy performance, we'll be looking at the comfort or thermal performance, we will be looking at the cost, the time that it takes to implement and commission the technology, and then we will produce a report that will be shared broadly with other federal agencies, as well as commercial partners in order to elucidate the value of the technology. You can go to the next slide, Marissa. And as I mentioned, we'll be answering questions at the end here, so if you have them, go ahead and type them into the question box. So the objectives of technology are really to, as I mentioned, verify that the technology performs as we thought, or to help us understand where the technology can improve so that we can make more investments in research. So some of the examples of metrics that we're looking for are around energy reduction, utility cost savings, peak demand reductions for grid interactivity, occupant satisfaction, and then where would the technology actually be applicable? So what system types, what building types, what size ranges, and you're going to hear a little bit more about that for each technology here, what the target application is. And as I mentioned, we'll be evaluating the commissioning requirements, maintenance requirements in operation, how easy is it to operate, how easy is it to integrate, and the cost. Next slide. So the roles of the different entities here are based on maintaining objectivity of the verification. So we'll have a vendor, and you'll hear from Doug, who is actually producing the insulation product that we'll be testing. But we'll also have the labs, our laboratory experts who will be conducting the verification. So the site role is actually to work with both the lab team, the verifier, and the technology provider in order to make sure that the test can be conducted so that we are producing useful and valuable information. part of that will include developing a monitoring and verification plan, the scope of the project, and then helping with access and providing information during the verification process. And the lab, as I mentioned, will serve as the third-party verification entity to maintain that objectivity of the validation project. Next slide. So this is the schedule we're on, and validations are difficult, but we're hoping to maintain, the most streamlined schedule possible. So site selection happening right now, installation of the technology, hopefully fairly rapid for the 3 technologies that we have. Evaluation will depend on the technology and the site because there are seasonality variables that we'll need to look at. And you can see right there in the link that there is a validation report available for you to take a look at if you have a question about what the end product looks like. These slides will be distributed as well. And you can go to the next slide, Marissa, and I'm going to go ahead and turn it over to Armando to talk about our first technology. Armando, can we hear you?
Hi, everything good?
Yeah, great, thank you.
Good morning, everybody. My name is Armando Casillas. I work at Berkeley National Laboratory as a scientific engineering associate, and I'm here to present to you technology called WISE Building, created by a company called FEMP Controls out of Virginia. This validation project is being conducted by myself along with Dr. Jessica Granderson and Dr. Guanjing Lin, also at Berkeley National Laboratory. You can go to the next slide, please. So the WISE Building platform, this is an overview of that, is a central multi-end use building system for small and medium commercial buildings. So I think that's pretty exciting, and the fact that for this section of the building stock, there isn't a lot of exposure or intelligence that is applied to this section. This platform provides single point access across many zones and devices, including thermostats, lighting, and smart plugs, and provides a customized dashboard and user-friendly control interfaces. So you can see on the right there on the top is the mobile version of the platform and the desktop version of the platform. The mobile version of the platform, you can see, has a list of all the connected devices that you can click on and see the status of and set points and things like that. And on the right, you have the room status of a certain room in a building with thermostat, set points and schedules of the like, things like that. So with this, WISE Building can really set up a small to medium commercial building with a lot of the intelligence that you would see in a large building BMS system. This WISE Building platform is going to be able to provide you optimization of your building operations, along with other things like demand response sequences, and guarantees at least 5% whole building energy savings compared to a non-controlled building, which is delivered through the smart control customized by FEMP Controls for the customer that is interested in installing this technology in their building. On the lower left here, what I'd like to highlight is a case study that FEMP Controls has provided with the link below that shows a customer that was having a hard time trying to mitigate peak demand costs. And you see the blue line there on the left plot is the demand curve, and around every hour or so the AC was cycling on and off. So a FEMP control data on the right you can see is widen the set points during that peak demand time and really substantially cut the peak demand during that peak demand window from 4 kilowatts to all the way down to half a kilowatt. So there's some really neat things that this WISE Building platform can do and provide this section of the building stock that wasn't really available before. Next slide, please. So in terms of installation costs, these costs are twofold, and I'll explain a little bit. Also, I'd like to say that these costs may vary depending on the number and types of devices that are being installed in the building, as well as the conditions in the building as well. And they're somewhat flexible, given that the use of the WISE Building platform is only going really to be for the 6 months of the evaluation that we're conducting. if you would like to purchase and continue the use of the platform afterwards, that's all fine. But these costs are more for a long-term annual sort of situation. So in terms of the one-time cost, we're talking about the purchase of compatible off-the-shelf hardware, and this is how the WISE Building platform operates. It needs these types of hardware with Wi-Fi sort of internet connectivity capabilities to really operate. So we have things like Wi-Fi thermostats, things like Ecobee Nest thermostats that can run anywhere from $70 to $200 a piece. IR controllers for split AC systems, lighted controllers, smart plugs, things of that nature. With that comes an installation and commissioning cost, which runs around $1,500. And on top of that, you have the annual recurring costs for software and analytics. So the software control, what you're getting is web and mobile access to all of the smart devices that you purchase, along with the single interface, optimized scheduling, and the demand response sequences, as well as the analytics portion, which provides full cloud access to the data if a building operator or a building owner would like access and insight on what's going on in the building real time or historically. Next slide. So we have a set criteria of characteristics that we'd like in the building that we'd like to install this technology in. We're talking to a group of folks in the federal agency. So basically any office building, any public sector building, we have here strip mall, school, hotel, basically any commercial building under 100,000 square feet. We would prefer something around 50,000 square feet, but anything under 100,000 square feet is fine by us. We're also looking for an RTU, a rooftop unit, or an air handling unit that's less than 10 years old and is able to communicate with a new Wi-Fi thermostat, and would really like the current thermostat in the building to be somewhat of a manual control, very rudimentary, basic control installed currently. We'd like the building to have the ability to upgrade to the BEM compatible hardware, to the thermostats, the lighting controls, as well as have access to a stable Wi-Fi connection, or at least allow BEM controls to go into the building and install their own independent Wi-Fi network. It's really nice to have the ability to install smart meters to do some additional analytics and sub-metering for certain end uses in the building as well. We would like whole building gas usage and electric usage data, as well as peak demand data. It could be interval, hourly or sub-hourly, access to that through the utility or through the just some other metering entity in the building. We also require at least 12 months of historical electric and gas data, so we can establish an adequate baseline for our evaluation purposes. A couple of other things I'd like to highlight in terms of considerations. LBNL is available to work with all of the federal agencies to review your portfolio. So if you have 5 buildings, 2 buildings, 3 buildings, 10 buildings that you think would possibly qualify for this, we'll do the heavy lifting of looking at the building characteristics and really trying to find the building we would see best fit to install this technology. And we also like to have the site work with BEM controls, the clear cybersecurity requirements, and really have an engaged staff, building operators that are able to use the platform throughout the process. We would like to have stable occupancy and operations, as well as internal loads in the building throughout the evaluation period. And this is just so we have a good apples to apples comparison of how the building was operating before the technology was installed, as well as how the building was operating after the technology was installed. On top of that, we need full documentation of as-built drawings and control system documentation information on how the system was operating before the technology is installed. Next slide, please. So in terms of host site responsibilities. This is whether it be the owner or the operator of the building. Overall, we'd like for you to participate in a 1-year-long study, maybe a little longer, and those things can get complicated, in terms of timelines and things like that. Maybe a little longer than a year, but the first part of the year would be the installation and purchasing of the BEM-compatible hardware. So this is the list of devices that I showed you on my, I think my third slide. The thermostats, smart plugs, smart lighting, all that, all those devices, off-the-shelf open API devices, basically meaning devices that are able to communicate via internet to receive and transmit things like status, set points, schedules, things of that nature. So the host site would be responsible for purchasing these devices and installing them in their building. After running the building with the new sort of setup, the new hardware, for 6 months, we would then go in and install the WISE Building software and really try to tinker with the software and really try to get and customize the software to fit the building operator's needs. And we would at that point run the software for 6 months and monitor how the building is operating for the 6 months. And the reason we're trying to do this is really to capture the incremental value that the WISE Building platform provides in the building as far as building operations and overall operational costs and savings. We are aware that there's a lot of technology out there now, hardware, that is able to provide already some sort of marginal savings with the heightened intelligence, but then to go in and put in a system that centralizes all that and provides connectivity across those devices, that's a sort of fuzzy line of how much more energy savings does that give you. So this is why we're trying this two-step approach in this evaluation process to see exactly how much the WISE Building platform is providing in terms of value and savings. The building operator must remain engaged across this whole timeline and properly operate the recommended BEM control sequences, as well as work with the interface. A big question in a lot of small to medium commercial buildings is who is using this platform, who is operating the platform at any given time. In larger buildings, they may have building operators. In smaller buildings, that might not be the case, but that's something that we would need to be working out before we actually pick a building during our recruitment process and selection process. So yeah, that's basically it for me. Thank you very much, and look forward to hearing your questions in a little bit.
Thanks, Armando. I think Robert, you're up next.
Okay. Can you guys hear me?
Yes.
Yeah. Okay. Hi everyone. I'm Robert Hart at Berkeley National Lab. Today I'm going to talk about the thin glass triple pane windows. I've been leading this project at LBNL for about 3 years now. Most of this time has been a focus on residential windows. We saw that as kind of the first path to market. But really the technology is at the stage now where we're starting to look at commercial windows, and we see a pathway forward to do these demonstrations in commercial buildings. So we'll focus on that today. Next slide, please. Okay, so the technology itself is pretty simple. We start with just a standard double pane insulating glass unit. You can see on the picture. And what we do is you drop in a thin piece of glass. This is anywhere from, say, the glass that's used in a big screen TV to something that's kind of in between that and standard or traditional window glass. You drop that glass in the center of those two panes, and you add a second, now that you have two gaps, you can add a second low E coating. You can add a couple other technologies, a gas fill in there as well. But that's really all that there is to it. So the performance you end up with is similar to a traditional triple pane unit, but you get a couple advantages that are really nice with most buildings. One is the weight. So for installation and depending on your building, if it can handle the skin load, you get a significantly reduced weight by using this thinner glass. The second is that you keep the same width as the traditional double pane insulating glass unit. So what that means is that frame manufacturers don't need to have a specialized frame to be able to handle this unit. There's a couple of advantages to that. Is if it's new construction, they don't have to design a new frame, and the frames are cheaper. Or those double pane frames are much higher volume than the triple pane frames that are out there. The second is for retrofits, so you can go back in, and if your frame is in good condition, there's no issues with it, but the glass has maybe started to fail or something like that, you can go back in and keep the frames, replace the glazing with the same width you had before, but significantly improve the performance of what product is going in. So next slide, please. So a little bit about that performance. So the kind of thermal performance, which I think most people focus on, and I should say that with these technologies, we would definitely like to focus on, say, heating dominated cold weather climates, into some mixed climates as well. Would definitely be viable options for this technology. But definitely with commercial buildings, we want to focus in that area. There are some opportunities in warmer climates with residential, but for these type of studies, we prefer to keep the colder climates. So the performance of say a whole window with a commercial frame. So if you have a say aluminum commercial frame that's already installed in your building and you want to go in and retrofit, if it has just a standard thermal break, you can expect somewhere about an R4 window or U.25 if you're talking more traditional window terms. And that's with an argon-filled product. If you have a better or more advanced thermally broken frame, you can get somewhere around an R5, and especially when you add krypton fill. If we go into a light commercial, which is something that's viable for this product as well, say schools or multifamily or low-rise multifamily, and those sort of areas where you could put in, say, a more traditional residential style frame. Performance numbers look somewhere around R5 or 6 or R7 even in the fixed window products. So a couple of other notes I think that are important, especially when we're talking about these bigger buildings, is and if we're doing, say, a retrofit, solar heat gain coefficient, visible transmittance, they're very tunable, just the same as they are with a double pane unit. If you're, say, doing one floor of a building and you want to leave the other floors existing, it's fairly easy as long as you know what the glass is installed to match the aesthetics of what was there before. So you'd be increasing the thermal performance, but leaving those other values about the same as they were before. As far as structural performance, so this kind of thin glass triple pane, the thin glass is generally treated as a non-structural layer. So you don't design the pressure performance for that layer to handle any of it. It's actually, because it's thinner, it's essentially doesn't carry any of the load. So you design to, just as you would have before, the window manufacturer would before, they design the thickness of the exterior lights of glass to match what's needed for the building. And this layer is just along for the ride. Units that have been tested for commercial, you can see there's a picture there of one that's a 50 square foot unit. That's the largest size that we've gone through pressure testing with. In that, I think, is probably definitely the limit of something we'd be looking for with these demonstrations. I think smaller would probably be better. They've been tested to, say, CW30, which is a pretty typical rating for low to mid-rise light commercial building. So again, that's kind of where we want to keep these technologies. And then one other is that these are vertical applications only, because of the way the thin glass is, the nature of it. We want to keep those at vertical installations, so no skylights or any sloped glazing. Go ahead and go to the next slide, please. So talk just a little bit about some of these benefits that we expect with this technology. Of course, the energy that most people hear about, we'll talk about that a little bit as well, but I think especially with commercial buildings, the more, the better case for using triple pane technology in general, not just this thin triple, but any high performance glazing, is the comfort benefits. And we're showing here just a little kind of heat map, or cold map, I should say, of what it looks, windows next to in the walls in a Minneapolis design day. Essentially, a triple pane level technologies can eliminate discomfort. So if I know most people here are aware of sitting next to a window, you feel that cold draft coming through. it's not always the cold draft coming through the window. It's actually quite often a cold draft along the window. So the cold surface of the glass, as it gets cold, it starts to drop. You start to feel this breeze coming towards you. It's usually not actually air leakage through the building. When you have something at the level of triple pane performance, that's eliminated. The glass temperature is much closer to room temperature, and you don't get that anymore. And what that often means is now you can do a couple things with that. You can increase your window size if you want and still be comfortable. If people couldn't sit next to the windows before because it was too cold, you're actually losing that square footage. You can gain that square footage back. And in some cases, you can actually even eliminate perimeter heating, right? Because you don't need to have that reheat next to the windows anymore. Go ahead to go to the next slide, please. So there's that image of what I just talked about. So if you have this very well insulated kind of facade, think of it if you didn't have any windows at all, you wouldn't need perimeter heating. It's the same thing when you get to this level of performance. This allows you to eliminate that heating. So if we're looking at a building here to do this installation in, if this kind of retrofit goes along with an HVAC upgrade, and doesn't necessarily have to be concurrently. If a HVAC upgrade is planned maybe 5 years in the future, or it's along the way at some point, this could be a technology to install now, knowing that when you do that other upgrade, you'll be able to downsize it for not just peak load, but you could also potentially eliminate some of the expensive systems that have to go to the perimeters. And of course, anytime you have a high performance building envelope, you have a more resilient building, right? Anytime it's very cold outside or it's very hot outside, it takes your building longer. Say if you lose power or something like that, it's going to be comfortable longer. Along with that, of course, you reduce your peak heating and cooling loads, and you make a more stable load for the utility. And another big benefit here, you say you have a setbacks for the weekends, and your Monday morning building warm up is going to be a lot shorter in these cases, or overnight if you have setbacks overnight. Go ahead and go to the next one. So just kind of a summary of some of those benefits that I mentioned. You're delivering whole building energy savings through just reduced envelope heat transfer, improved satisfaction and comfort from the occupants, and for commercial buildings, I think we feel this is the biggest benefit. The more comfortable your workers are, the more productive they are. Reducing the morning warm-up time and load, less load to the utilities. If you're considering doing these high-performance envelopes before, say with the traditional triple pane units, there's definitely some advantages to installation costs doing these thin triple versions. So materials and installation cost from labor side. And then of course, if you're looking at doing other technologies down the future for HVAC, you can look at your capacity downsizing, perimeter zone and elimination. And next one, please. I believe that might be it for me. Oh, no, one more. So site requirements. So I think I mentioned this a little bit during the other slides, but at this stage of the commercial building demonstrations, we're looking for on the buildings on the smaller side, it needs to be low rise. So low rise offices, small to medium sized buildings. Punched opening style frames would be the ideal case. We can do strip windows as well, but nothing like a high rise commercial facade, something like that. That's not the right application for this at the current time. If you want to do, say, replace the entire frames and put in really high performance, say, fiberglass framing systems, that's typically what's used when you want to have the highest thermal performance in a commercial building. Just we have to check local fire codes and those sort of items to make sure that that's an acceptable framing material where you are. But if it's just a glass replacement, then we can look at the performance that way as well. And I think as mentioned throughout these presentations, we want to be able to meter these units, so we can do metering of the building itself, but then we'd also like metering of the windows themselves in select locations. some surveys of the building occupants to determine comfort. Again, comfort is a big part of this product, and understand from the user's point of view how their comfort has changed. So from the baseline to this technology. I think that's, yeah, I think those are the kind of primary characteristics we're looking for. So I'll ask Marc LaFrance from DOE to chime in and see if he has anything he'd like to add.
Okay, thanks, Robert. Yeah, I think you did a great job explaining the overall technology and how it can be used. The only thing I just want to iterate a little bit more is on the economics, right? So generally, when people look at windows, if you're looking at a building just to do, any energy efficiency upgrades, modest types of things, windows are usually not the most cost-effective thing to do. A lot of cases, they're cost prohibitive to do. But so we're really looking for a building that, like, the windows have reached the end of their useful life, and the building needs new windows. And so once you made a decision that we need to get new windows in this building, then going to a triple pane and a thin triple makes lots of economic sense. And then, like Robert said about this holistic systems level approach, you can really reduce any premium associated with the windows if you can downsize the HVAC. And that can be, at the same time you're doing the project, or it could be a year later or 2-3 years later. So there are some really nice system level benefits when you look at the economic side of this. Another key application is if you made a decision that you want to achieve a zero energy building, or close to zero energy or zero energy ready, windows make a lot of sense, because there's so many benefits from having high performance windows. And then, we're definitely looking for different types of applications. It doesn't have to be a whole building. It could be one portion of the building. There could be some concerns about matching the aesthetics on the outside of the building that Robert could address. But we're willing to work with people to see what you have in mind, and what we could do together to really demonstrate the benefit of what a high performance window has to offer. So I just wanted to make those few points, but thanks.
Great, thanks, Marc. Thanks, Robert. And I think at this point, we'll turn it over to Doug Lamm to talk about minimally invasive insulation. Doug, can we hear you?
I hope so. Can you hear me?
Yes, great. Take it away.
All right, great. This is Doug Lamm with Building Envelope Materials. I'm going to present a new technology for minimally invasive retrofit insulation of buildings. This is a technology that was developed over the past 4 years by my company in collaboration with Certainteed, and also a grant we received from the Building America program at DOE. The original problem that we actually were trying to solve was in houses, and the idea here was, is there some way to get 30 to 40% energy savings in houses without tearing off all the siding and putting foam on the outside of the building, and which is what's typical of a deep energy retrofit. And when we looked at this problem, what we discovered is most of the cost actually was involved in the walls. The technology for the roof and the attic is pretty well developed, but the walls and the windows, resetting windows, resetting eaves, all of that stuff was very expensive. So we were really focused on walls. After we did houses, we realized that this technology really actually makes more sense in larger buildings, because larger buildings are dominated by walls. So that's, as we go to market, initially our focus is going to be on larger buildings, and then longer term, we're probably going to go back to single family homes. Next slide, please. So the technology we refer to as pinhole insulation, and it's really in concept dead simple. We're essentially just drilling a 1/4-inch hole in a cavity and filling the cavity with closed cell polyurethane foam. This material that we use is very similar to spray foam. it has a different catalyst and also a different blowing agent, but the properties are pretty much identical to closed cell spray foam, so we're getting about a R6.5 or even higher actually with the material that we're using. The key sort of trick in making this thing work is a calibration process. And it's not that complicated, but nobody had really ever done it before. So essentially what we do is we shoot a known volume of material into a known wall cavity. And based on that wall cavity, we develop a fill rate. And every building has a slightly different fill rate. And then once we've developed our fill rate, then we basically just do simple math, and we can calculate how long or how much material to shoot into cavities that are of different sizes. And this process is the subject of a patent application right now. In addition to the basic process of putting material in the wall, we developed under the DOE grant what we call a talking rig. And the talking rig is a mobile unit. It can basically go into any building. So unlike, say, a spray foam rig where you have a very long hose, this thing we can wheel into virtually any building and insulate the building. The most important part of the talking rig is, as it sounds, is the audio feature. So what this thing does is it monitors the volume of material that a technician has put into the wall. It monitors basically every half second or so, and it counts out to the technician exactly how much material they've put in the wall. So, so that really helps because when you're actually injecting, it's very hard to see to see a display or something like that. So the audio feature is really easy for people to use. The second thing that it does, which is very different than in spray foam, is that it monitors quality of material. And so when you're putting material behind a wall, you can't see the material, so you really can't tell how good is the quality of the material that you just injected into the wall. So we use flow meters to actually monitor quality. And this thing, after we finish a shot, this unit will tell the technician not only what the ratio of these two components that are part of the polyurethane are, but it will also tell them how to fix the problem if we're slightly off ratio. So benefits of the technology, obviously it's minimally invasive. You can see on the bottom of the slide there a typical hole. We'll patch that hole with lightweight spackle. It takes like 30 seconds to patch that hole. We can inject into empty cavities, but we can also inject into cavities with fiberglass, and that's critically important because about 75% of all buildings have fiberglass insulation in them. So, so we've figured out how to do that without voids. We validate the fill of every single cavity with an infrared camera. So the material, after we inject it, it heats up, and in about 2 minutes, we can shine an IR camera onto the wall, and we can see very clearly how good our fill is. We virtually never get any voids, but if we did have a void, we could see it with the IR and we could fill it afterwards. And then finally, without going into a lot of detail, there is minimal blowout risk of this technology. And by blowout, what we mean is overfilling a wall. So if you talk to contractors about doing this sort of thing, the first thing that comes to mind is that they're worried about putting too much material into a cavity and then blowing out the drywall. We basically have a process that virtually eliminates that potential. Next slide, please. As far as applications go, we are currently primarily commercializing with the Boston Housing Authority in Boston to do large brick veneer affordable housing units, and you can see one of them that we're doing right now in the upper left there. That's an excellent, brick veneer is an excellent application area for us because it's pretty much impossible to use cellulose or to do anything from the outside on a building like that. Under-insulated single-family homes, of course, are where we started and are a great opportunity. Uninsulated shallow cavities, as you would have in, say, a row house, where the cavity is just about an inch deep, would be ideal. Historic buildings. You see a picture of the Guggenheim Museum. That building was actually insulated with a similar process where they injected foam. It was a much more invasive process, but that had empty cavities, and they injected that one with closed cell polyurethane foam. And then most importantly, older office buildings. This would be a key market for us. As long as the building has cavities, we can probably do them. Next slide. This slide just shows some data, the best data we have so far on effectiveness of what we're doing. As far as cost, somewhere in the $5 to $6 per square foot range for an under-insulated building, meaning a building that has fiberglass insulation in it already. The benefit, what we showed in this building, this is an affordable housing unit in Rhode Island, and we monitored the runtime of the HVAC system in 8 units. And 4 of those units were injected and 4 of the units were uninjected. And what you can see in that little chart there is, as a function of outdoor temperature, the runtime on the injected units was greater than 25% less than in the uninjected units. So generally, and we've had similar results in other buildings. So we're generally looking at somewhere around a 25% reduction in energy use in sort of wall-dominated buildings. Next slide, please. As far as site criteria for what we're looking for now, obviously brick or masonry veneer are great. Under-insulated fiberglass cavities of any type are good. Shallow cavities where you have, say, strapping over concrete block, or very common kind of construction in commercial buildings, would be terrific. HVAC systems, we're currently mostly doing electrically heated buildings, simply because that's where the biggest payback is. But we could do gas and oil. That would be fine also. No single pane windows in the building. And the reason for that is if there are single pane windows, you really need to do something about the windows before you do anything about the walls. So that would be really important. And then, if it's a building that has very high energy use intensity or very high energy costs, that would also be desirable as far as showing significant benefit. Climate zones 4+, we're probably not going to see huge benefits in climate zones 1, 2, and 3. And then, of course, we'd like to be able to access data. We'd like utility bills for at least 2 years, and the ability to install smart meters. And then the willingness on the part of the building owner to allow us to monitor energy use for at least a year. So I think that's it for me.
All right, great, thanks so much. So we had 3 presenters, technical presenters, to talk about technology. Thank you all for sending in your questions. We have quite a few. So I'm gonna give Doug a minute to catch his breath from presenting, and start with a question for Hayes. So Hayes, as far as paying for the technology post-installation demonstration validation, what is the plan for FEMP partners?
Sure. So Amy, this is Hayes. So FEMP is definitely, we're going to work with the agencies and work with BTO on funding for the validation. effort itself. I believe the question is specific to after the validation period is over. So clearly for some of the technologies, for things like the windows and insulation there, we'll work with the agency on, what are those ongoing costs we may be minimal for things where things like software licenses are needed. That's where we may need some ongoing support from the agency, but we'll discuss those if folks are interested, and look forward to collaborating and working on that issue.
Awesome, thank you. And then 2 quick notes for all of you. Tomorrow's webinar, which you may have seen an invite for, is the same as this one, so you don't need to come twice unless you want to hear it again. However, now that you've heard it, you can feel free to reach out to us if you have specific questions that come up after we close out. And then one more thought about schedule. Thank you, Eric, for bringing this up. As you all know, there's a pandemic happening across the world. Our schedule may be affected by that. Actually, it won't may be affected. It likely will be affected by that. So please, take that with in the context of what's happening right now in the world. So I am next going to ask Armando to answer this question. Can WISE building be run on buildings that operate data locally and can't allow cloud-based data for cybersecurity purposes? So I think, that's getting at, can we run it locally in the building? What are the cybersecurity protections?
Yeah, that's a really good question. And that's, as I was detailing one of the requirements, being able to set up a Wi-Fi network, I kind of thought to myself, oh, these are federal buildings. I don't know if that'd be allowed. That is a very good question, and I think that it's something that I would need to follow up with BEM controls about. I really do think that it should be okay, but there might be some of the capabilities of the platform that might be sort of lost because of the fact that data can't get from the building out to their cloud for optimization or algorithms, whatever technologies they have. The capabilities of the platform might not be the same, basically, is kind of my short answer.
Okay, so that may be a case-by-case question as well.
Yeah, and definitely, and it'd be something that I would, if whoever asked it, would love to get their contact info, and I could follow up with them afterward in terms of BEM controls and what they sort of have in terms of flexibility.
Great. Okay, there is a question here. Do we have to participate in all 3 sites? No, you do not. You can choose one and or choose 2 if you'd like. If you have interest in multiple, that's fine. But we're really just looking for a building for a technology. So hopefully that answers your question. Thank you. Okay, next question for Doug and Eric. How does the insulation technology address thermal bridging?
Well, this is Doug talking. Obviously, we're injecting into cavities, so this is not continuous exterior insulation. So it's not, there's probably no way that you could compare this really to continuous insulation on the outside of the building. If you had the funds to do continuous insulation on the outside of the building, that's probably going to be your better bet. But of course, that's, a house to do that is going to be $100,000, and you could do our technology for, maybe $5,000 to $7,000. So it's just a whole lot more cost effective. The cost benefit ratio is a lot better with our technology.
Okay, and there is a question about the costs that were presented on the slides and if there's a reference for that. So perhaps we can follow up with that specifically and include on the slides as well. Next question is for Doug and Eric as well, and that is regarding the electrical. I'm sure you've had questions about this, but how is the existing electrical wiring affected? What if you have to add wiring later?
Yeah, we get that question a lot. So it's pretty much just like existing spray foam, or sorry, just like spray foam in the sense that you want to have a pretty good idea of that your electrical is, if it's in the walls, is where it's going to always be. Because just like with spray foam, it pretty much locks it in. If you do need to change electrical, what typically they do is, rather than trying to sort of dig wires out, they'll just build a new raceway for the wires. It's sort of like a slot in the wall, and they'll put the wires into that raceway. So it is doable, but you would pretty much want to be sure that your wires are where they're going to be in the long term.
It's I might add, this is Eric from DOE. I might add that you know, abandoning old wiring that's been encased in spray foam is really has no effect on the thermal performance of the wall. So it's really just, if you need to do rewiring for some point at some point in the future, you just abandon the old wiring and do the chase as Doug described.
And that's Eric Werling from the Building Technologies Office as well. So thanks for jumping in, Eric. We do have a question about the exposure risk associated with the foam. So do you want to talk about that a bit, Doug and Eric?
Yeah, I should have.
You know,
go ahead, Eric.
I was going to say that I should start that, since you know, indoor air quality is a big focus of the Building America program, and so we've had these discussions offline, and we've also dealt with, through Building America, you know, many of the indoor air quality issues of concern. Spray foam is can be an indoor air quality issue, but it's by far the biggest health risk associated with spray foam is during the spray application, and the exposure is to anybody who is not protected during that exposure. With one additional issue, which is that some of the most egregious health risks associated with spray foam applications are when the spray foam is not done properly. The mixture if the mixture is not correct in a typical standard spray foam application, then you can get significant off-gassing of volatile organic compounds that are not healthy, when, you know, for especially people who are compromised. And so getting the mixture correct is a really important thing for spray foam applications to be healthy. And this particular technology, as Doug described earlier, actually does a better job of ensuring that the mix is proper for the spray foam application than standard legal spray foam rigs. So this is, if anything, it's an improvement on that exposure, but it does not replace the need for the technician to use proper, you know, OSHA follow up proper OSHA guidance for health protections during the application. And of course, any occupants in the building, we wouldn't, you know, the guidance would be for them to not be present during the application itself. Doug, if you have anything else to add to that,
just very quickly. So we've had 3 rounds of independent air quality testing done while we're actually doing the work. And in all 3, they were not able to detect any particulates, or virtually no particulates, as we were doing the work. So we don't allow anybody in, when we're doing an apartment building, for instance, we don't allow anybody in the apartment that we're doing, but people can be in the rest of the building, just not in the particular place that we're doing. And then the re-entry time is 2 hours after we're done. And that's all been validated with third-party testing, which I can send to people if they're interested.
Thanks. So 2 more questions. Doug and Eric. Sorry, Mark and Robert, but if you guys have questions on the other technologies, send them on in. So sometimes voids between exterior finishes and blocks are used as a way to help water escape. Will you do an analysis to make sure that the foam installation does not interfere with this feature?
Yeah, so we only, if there's masonry on the outside or brick on the outside, there's typically an air gap behind that brick, and then sheathing, and then basically a wall cavity with sheathing on one side and drywall on the other side. So our material doesn't go into that gap. So that shouldn't be an issue. We don't, in other words, we don't fill the air gap behind the brick.
Great. Okay, last question at this point. How long does it take for the foam to set completely?
It takes, it's like pretty much any two-component system, whether it's epoxy or polyurethane. It takes 2 minutes to harden, and then for complete full cure, probably 24 hours, something like that. It's a very quick hardening material, but then to come to final complete curing, it's probably 24 hours.
All right, great. Well, thank you very much. That's all the questions that we have. Oh, yep.
Oh, Amy, this is Marc, LaFrance. I just wanted to elaborate on one of the answers to the question. People might not know, but I managed building envelope for 10 years. And so the question was about thermal shorts and the cavity insulation. And so I think that if you're trying to get to a very low energy or zero energy building, you can do both measures. Basically, if you have a cavity that needs to be insulated, this is a great technology. At the same time, if you're going to be doing the siding, replace the siding, then you can add exterior insulation. And adding the exterior insulation is not that expensive if you're doing the siding anyway. At the same time, the Europeans have put 4 inches of exterior insulation, but that's extremely difficult, and the U.S. is not really doing that. So we're pretty much limited to maybe an inch is pretty easy, or maybe even 2 inches. But if you only put an inch of exterior insulation, that's a great measure to do by itself if you want to make the building better. But if you really want to get to low performance, which we're striving for, you really should be doing both the cavity and exterior insulation. So I just want people to think that it's not like you do one or the other. In some cases, you can do both. I just wanted to give people that context. So anyway.
Yeah, that's a great point, Marc.
Yeah, thanks so much, Marc. Okay, so actually, one more question that came in while you were talking, and it is about the age of the buildings for all 3 of these. I will let each of you jump in. I suspect this is going to be most appropriate for Armando, though, so I'll let Armando go first. Can we still hear you, Armando? Is there an age requirement or limitation for building-wise?
Not really. I'd say the main thing would be that the air handler and RTU is less than 10 years old and is able to communicate with the Wi-Fi enabled thermostat. In terms of building overall age, I would actually think the older the better in terms of having in place more sort of analog manual thermostats and lighting. That's something that we're looking for, actually.
Great. And Robert or Marc, thoughts on the age of the building?
Yeah, there's no real age limit for the building. I mean, if your building is quite old, still has single pane window, I would say that's a really good case. I think it was mentioned before, the insulation. It's if you have single pane windows on your building still, especially if you're in in a cold climate, you need to get those out of there. So this would be a great technology for that. But I think it's more generally if you're double pane windows, if you're having something failing, you need to replace the windows. That's when this is a good option to do.
Yeah, the only thing I would add is it's just not necessarily the age, how old the building is. It's how long does the building, are you expecting the building to stay in service? So people also mentioned previously about, well, I think Doug mentioned about if you have a single pane glass window, it's not ideal for doing the walls because the windows are the worst case. But actually, you should do the walls, which is a good measure. And then if it's a single pane glass window, and if you can't afford to put in a new, thin triple, you could put on a secondary glazing low E window because maybe it just gives you a more affordable option. We want people to replace the windows whenever they can, but in some cases, it's just not economic for them. They want another solution. So there are multiple solutions. But of course, if you have a double pane window that has failed and you have condensation and people can no longer see through the window, I mean, you can see through it, but not clearly, and the window definitely has to be replaced, then thin triple is perfect. If you have a single pane window, you want to do the right thing. Yes, we want you to put in a thin triple, but there are other solutions. And so, depending on the service life expected is a key element.
Thanks. And then Eric or Doug, any thoughts about age of the building?
Yeah, so in theory, we could do buildings of any age. What we found in practice is that when you're looking at single-family homes, pretty much any building is okay because it has wood cavities. But when you're looking at larger buildings, the target seems to fall into the 1900 to say 1980. Those seem to be the best years for what we do. The big reason for that is that older large buildings tend to be mass masonry, and so we're not doing mass masonry buildings at the moment. And if it's newer than say 1980, then it probably has reasonably good insulation, not necessarily. And if it's bad insulation, we'd be interested, but newer than 1980 typically already has reasonably good insulation in it.
All right, great. Well, there are a lot of buildings built before 1980, so that's a good sweet spot. Okay, so thanks everyone for joining us. Hayes, did you want to say any last comments or wrap up for us?
Sure, thank you, Amy. This is Hayes Jones again from FEMP. I just wanted to let all the agencies on the webinar know that if you're interested in hosting one of these technology validations or would just like to learn more and talk about your specific application or specifically what you're interested in, please contact me. My name, email, and phone number are all listed there on the screen. So please be in touch. Look forward to hearing from you. And these folks are available for follow-up questions. If you didn't get your question specifically answered, or if you needed to follow up for more details, we're happy to get the right folks on a call, on a webinar, and get you the information that you need to make a decision. And from FEMP, we look forward to continuing to partner with our federal agencies and with our sister office in EERE, the Building Technologies Office, on this great opportunity to validate technologies and see these in our federal agencies and help agencies achieve their mission. So please be in touch and let us know if you have any questions.
Thanks so much. Bye, everyone. Have a great day. Stay healthy.
Thank you.
Bye.